Welcome to my talk about Micro Frontends. I don't know these three people. I don't even know if they exist. They are generated by ChatGPT, but in a way that represents the evolution, I would say, when you are interested in Micro Frontends. You first start a little bit naive. You think everything works, everything is wonderful. Then you need to start implementing it, and it becomes a little bit more serious. And then once you have gained a little bit of an experience, you know that things are not that easy, and this is exactly what I want to explain in this talk. So, introduction, my name is Rainer. If you hear a very similar accent to Michael before, that's not a coincidence. We are coming from the same country. We are from Austria. Exactly, yeah, and no kangaroos, yes. And I'm part of Angular Architects, so we're doing consulting workshops, and I also try to be very active in the open source community and also do an Angular newsletter, which is called NG News. So let's start with a little bit of a story. Let's say we have here an application. Let me quickly start it. By the way, it's the same application that I wrote last year, but now it's a little bit different. So if I load it here, not this one, but this one, then you see here that somebody has written a quiz application. So you can answer here questions, then you're getting a status information, and something like this. And let's say the one that has written the application approaches you and says, look, I have this application. Maybe it's a good idea to integrate it into your application. Because what we really have, let me quickly close that application. Let's go to the other one. We are here a travel agency, and we are selling vacations, holidays, and so on. And then we think, okay, this quiz feature might be a very good fit in addition to our application, because I could say here, for every holiday that I'm selling, I'm providing here a feature, a quiz, where people can learn a little bit about the country, and then maybe also we can sell more holidays. But there is one catch. That other application, that quiz application, I can't just simply take the source code and copy it into this application. They want to have a separate development. So this is a separate team, and they are saying, no, we don't want to push into your repository. We want to stay autonomous. So we want to develop as we want. We also want to be able to kind of deploy whenever we want. So we want to keep it separated. And now I say, okay, this kind of sounds like Micro Frontends, which means we have multiple applications which are merged together during the runtime. This is what we want. And you probably heard about the terms module federation, native federation before. That's the modern approach. And you're deciding now to try out one of these. Now the way how it works, by the way, in module federation, native federation, they are very similar. So the approach is kind of the same. But since we are using native federation, or we created native federation, I'm obviously going to use native federation. But if you use module federation, it's going to be almost the same. The way how it works, and this is very simple, the principle or the approach, is that we say it would be the best thing if we can keep everything in one Angular application. And the trick there is to reuse or to kind of integrate it via lazy loaded modules. So when you have a routing configuration, for example, let me quickly open it, that you have here always this property of load children, where you have an import. And the advantage of that is that now Angular, during the build process, Angular says, I'm taking this customer routes with all its dependencies, and I'm not including it in the main bundle, but I'm just including it in a separate JavaScript file, which is then loaded once the user is going to this route. And we also see this here in the build. So you always have here the list of all the lazy loaded chunks that you have, customer routes, booking routes, all of that. And the idea now with module federation, native federation, is that we say, in this case, the chunk files, they are taken from the existing application. But what if we have another Angular application which just also builds its own chunks, like this quiz component can also be a chunk file, and we'll just load the other chunk file and load it directly here into our so-called host application during the runtime from a different server. That's the basic idea. We just take another chunk file, another lazy loaded module from an Angular application and integrate it right into it. Very simple. It's not that simple when it comes to the implementation, and therefore we need a certain kind of a set of tooling, and this is exactly what Module and Native Federation are doing. They are tools which allow us to do exactly what I just said, doing lazy loaded modules from a different applications. What do I have to do? Well, first of all, I need to stop my Angular application. You obviously need to install that library, and then it comes with an Angular generator. So I say here Angular architects. As I said, this is coming from us. Native Federation, I'm going to say init. And now I need to tell my Native Federation what kind of type this one here is. That's the main application. And in the terminology of Micro Frontends, we call the main, that's the shell. And in Native Federation, I don't say shell, but I say dynamic host. Good, wonderful. Angular architects, Good, it asks me for a default configuration. Now it does some changes. And if I now say I want to rerun the application, it takes a little bit longer because now this tooling needs to do certain analysis. We will then cover what exactly that actually means. But in the end, the application starts and it looks like as it was before. Good. I'm doing now the same thing for my other one as well. And the other one, if we want to call it, that's the Micro Frontend. Or then in the terminology of Native and Module Federation, that's the remote. Which means I'm going to re-execute the same command in it. This time I am saying you are now a remote. And then I'm saying you also need to run on a different port because I want to have two applications running at the same time. So also do it like this. And then what I also now have to do, and now it becomes interesting. I can't just use the lazy loading mechanism of the routing system of Angular. There is a little bit more necessary. And in order to set things properly up, there is this federation config.js, which has now been added. And in this federation config.js, you just say here which components you want to expose. That's like this chunk that I've created before via the routing system. Now it's almost the same. And I say this quiz that I had, I only want to expose the quiz component, not the complete application, of course, but only the quiz component. So I say here quiz. And then, of course, I also need to provide the path. And if we look into our application, then the quiz component is located into source app, domains, holidays, and then we're coming into the quiz. So I'm typing this in, domains, holidays, sub quiz, and it's the quiz component, hopefully. Okay? Then I'm going to restart the whole thing again, the complete application. Change yourself. Takes a while. And what I have to do now, once this is running, that I now need to make sure that my other one, my host, can actually load it. I know how I can load it. I know the name of it. It's going to be quiz. And I also need then to tell my router from which URL it could kind of load this chunk file. And that's why I'm going into my routing system. If you remember, I said, you probably don't see it that well, but if I hover here with my mouse over it, I have already prepared a link for the quiz. It says holidays/quiz, and then comes an ID. And this is where I want to load now this remote into it. So I'm going into my holiday routes. And then I say, okay, very simple configuration. It's just another path where I say, here we have our quiz. It comes with an ID. And then we are loading a component, but we are not using the normal import. Instead, we are now using something special, which is the load remote module. It's now a different command. And in it, we then say remote entry. So we need to provide here the URL. where I say, okay, it's coming from, that's not right. ChatGPT wants to make it a little bit harder. Localhost 4200, one remote entry JSON. We will look at that file later. And I say the exposed name, the exposed module is the quiz. Yeah? So it's like lazy loading modules, but just with a special command. I also need to do a small change here. Manifest, going to remove that one because I don't want to see the error message. I'm reloading the whole thing, the complete application. And now, check out the network, because now I'm going to click on this quiz. And now the whole thing should start to communicate with this other micro frontend, with that remote, and will try to load the chunk and integrate it into the existing running Angular application. I'm not sure if it works. Let's give it a try. Yeah, lucky. You see here, there was a communication. Let me make this a little bit larger. There was a communication with a remote entry JSON. The communication went to 4201. It's a different URL. We have the quiz. That's the quiz component with all with everything that is necessary, with the services, the components, the subcomponents, whatever. And then we also see here something additionally, and that's the nginx signal store. And the reason why the signal store is loaded right now, because no one has been using it before. But we see here also that nothing else is loaded. This quiz JavaScript file, it's just 14 kilobytes. It's very small because it only contains the application code. No dependencies, no Angular framework, nothing. Yo. And that was it already. I mean, not really. We are going over it again by using here some slides, but there will be something which I still want to tell you, something very important. But what we have seen so far, let's recap. We have here micro frontends. Yeah? In this case, we have two applications. We had just one. We had just one micro frontend. Those micro frontend, they expose their features that they want to provide to our server, to our shell, as a lazy loaded chunk. This is why we have here a green and a blue one. On the right side, we have the shell. That's our platform, our host, whatever you want to call it. The shell is the one that our application is then also where our users are navigating to. Both shell and the remotes, the micro frontends, need to be compiled. And this is now where it becomes interesting, because it's not a typical compilation process. There is a separation of the files. Because what Module Native Federation are doing, that they are saying, we can't just put all the dependencies together with the components. We need to split the application code from the dependencies, from the third-party libraries. I will explain why this is the case later. But we see that these lazy loaded modules, they are very, very small. And what happens now when the shell is loaded, that the shell says, look, I'm going to provide you with the complete Angular framework. Everything which is necessary comes from me. This is what I'm bringing in. I'm also bringing in certain libraries that my shell also requires. Then, when we are activating a micro frontend, I'm going to load more or less this bundle here, the lazy loaded chunk. And not the Angular framework. So the Angular framework is already there. We don't need to load it anymore. We don't want to have multiple Angular frameworks running. It should be one. And what happens now is that this chunk will tell the browser what kind of dependencies it has. So it will, for example, in our case, say, I want to import Angular, I want to import Angular material, I want to import the nginx signal store. And then the browser is smart enough to understand what dependencies it has already loaded, and it says everything is already there except the signal store. Then it says, okay, then I just need to load the signal store, but not the rest. And this is then why it is so important that all the libraries that we are using are completely separated, that we can very specifically load a certain library which we don't have. And this works under the hood. We don't have to care about it. It just works. Native Federation, the way how Native Federation, for example, works, if we look here at the holidays again, where are we? Not Lübeck, India. If we look here again at it, then we see that the quiz is saying somewhere, you see here, I'm going to import something from NGRX signals, I'm loading to import something from Angular core. Well, the Angular core is already there, nothing to do. The signals are not there, so I need to load it. What both systems have is this remote entry JSON. That's the key file for the communication. We haven't seen it now, but let me quickly open it. The remote entry JSON from the shell contains all the information about the libraries that the shell has, and also with the version. That is important for later. So we get here a complete list of everything that the shell provides. This is also necessary for the browser, because the browser needs to know when somebody is saying import CDKey portal, it needs to know which kind of chunk file it needs to load. This is all coming into the browser. And the remote entry has the same thing. It also says these are the dependencies that I'm using, and these are the chunk files and whatever and so forth. Good. These two are communicating with each other because there is something very important. The versions need to match. So you see here that there is everywhere a strict version and also singleton, which means that in this setup, we are saying NGRX, it's 19.1. In the shell, in the remote, both need to match, otherwise I'm going to throw an error. That's the default setting. But other than that, we don't need to do anything else. We don't even need to look at the remote entry. You only have to do this if you need to do some kind of debugging, but usually that just works out of the box. So this question mark here, this is done with module federation logic. They will take care of us. So, and then we can say, and they lived happily ever after, if there was not a problem. If you remember, I said before, this quiz team, which implemented this quiz feature, they want to be autonomous. They want to say, we want to do our own stuff, separate deployment. I hope that by now everyone understands that this is already possible. This quiz team, they can update their files as often as they want. They don't need to kind of synchronize with the shell team. It just works because we always load the file from the remote. But what if the team now says, well, that's nice that we all have now a strict version, but what if I can't do this? What if I'm, for example, now running on Angular 18 and the shell is using Angular 19? Then we have a problem, because we want to have one single Angular instance. I don't want to mix things up, because then I have multiple Angular applications and I'm losing a lot of the advantages. Then we can say, okay, good, I am going to accept it. There is something which we call semantic versioning, which means Angular promises us when the major version changes that then we can expect breaking changes. So we could now say, okay, if we make sure that the shell, which is running the Angular, the runtime, if the shell is always running the latest version, let's say 19, then because of the semantic versioning, we can say all the remotes, they at least need to use 19. That is important. This is something we hopefully can manage. And this is now where the challenge starts, because this is not the case. I have prepared here something. The way how it looks like. Let me quickly open here this link. This is also from Mathieu, that Michael, where is he? Has introduced before. When we are writing code, then we are using this stuff here. So we are using normal commands from the Angular framework. What the Angular framework is doing when it compiles the code, that it is generating something like this. Okay? We are never supposed to write code like this. We always write code like the one that here on the top. Because this here is the public API, and the compiled version, that's private. And there are now certain rules when it comes to semantic versioning. It is only valid for the public API. Which is why Angular is saying, look, as long as you're providing that code to our compiler, we will guarantee you the semantic versioning. That will just work. But if you start to load things like compiled code, which is using commands which are not under the public API, then we are also not bound to this semantic version. And what that means is that Angular is allowed to introduce breaking changes in this code, in the compiled code, for example, between 19.5 and 19.6 on a patch level. They are allowed to do this. And that's the big problem that we have with module and with native federation, that if you want to play it safe, you have to use exactly the same version. That's also why the strict version is enabled by default, and also the singleton. Because we want to protect you, we want to tell you, look, there is some version mismatch. That is not, you're running a risk that it might not work. It's a risk. It could work, but it could also not work. The official statement from Angular is, if it doesn't work, don't expect any help from us. We are not supporting this. Don't expect even that you get an error message. We can't even tell you what will happen if there is a mismatch between the compiled code. And again, let me quickly open here this quiz. The code that we see here that is loaded into the runtime is also using those compiled commands. So here you have it. Element start, these are all things which are not public API. That's the problem. So this is very important to remember, because very often, as I had with the cover, we are very naive. We think, yeah, everything now works. I can mix everything together. No, not really. We have to be very careful. So the same version is the top challenge when it comes to the module native federation approach. You also, of course, need to share everything. So, I mean, you could load NGRX multiple times if they're on the same version, but what's the benefit? You want to have a singleton. If you load it multiple times, you're also running into issues with the dependency injection and that stuff. It's solvable, but you don't want to do this. Another important thing, especially if you care about the bundle size, you don't get tree shaking. And I hope that's now also clear why. Because if the shell is now generating the NGRX signals chunk, then it says, I don't know what remotes, what micro frontends are being loaded. I don't know what kind of features of the signal store my remotes are going to use. But I'm the one that needs to provide the signal store. So again, I have to play it safe. I have to provide everything that the signal store has. I can't do a tree shaking. And this is also what we see, for example, especially if then where micro frontends are really used. There are always some specialities that you need to do on your platform. Your shell, you want to use, I don't know, certain shared libraries. You want to have a communication channel. You want to have an authentication, whatever. There is some special knowledge required if you want to maintain a micro frontend architecture. And we always see in the companies that are able to use them successfully that there is a very special team with a deep knowledge on how these things work. And this is something that the company must be ready to invest. Don't forget this. We could not say, okay, if this is such a big thing with the same version, isn't then the monorepository the best approach? This will bound us to it. Yes, it is. But then again, you have the challenge that you have multiple applications. They all want to be autonomous, but then you still have to kind of narrow them down and say, yeah, you can do whatever you want almost, as long as you all stick to the same version, which is quite a big constraint. NX in this case is the one that you want to use. So if you have a monorepository with multiple applications, then NX has the tooling, everything ready that you want to use. Do we have alternatives? If we say, no, this is not something which we can do, they are running on Angular 16, the other ones are running on Angular 12, we are running on 19. Are there some other approaches? Yeah, there are. So you can use iframes. That's a very ancient technique. It still works. It is still used in public. Not public websites, but more for private, for internal applications. You have full isolation, but you have other struggles. Let's put it like this. Web components can also be used. Web components can even be combined with module and native federation. So for example, you could say you have a very, very special remote, a very special micro frontend, which is running on a completely different Angular application, and then you can integrate it via web components. But you have to be aware that's another Angular runtime, a second one, which is then running. But it works. It is possible. For your management, when they are saying, well, we have seen the success story of the microservices. Why is it so complicated? We want to do it in the micro frontend as well. No, this is not the same, please. It's not the same. First of all, you don't have this requirement for scalability. When you say microservices, you have a huge amount of users and you want to scale your servers. This is not what you need in the front-end world, because per node, every node is the user, so that every browser is its own node. You don't need to scale that. Why? It's a completely different context, setting. We don't have a full isolation. That means there is a global window object, there are other global objects, and all their micro frontends can access and override them. This is risky, especially if the framework that you're using is not prepared to support micro frontends. They are just overwriting certain things and they think they are the only ones and nobody will come after them, which is not the case. And especially for Angular developers, the Angular framework does not support micro frontends. We hope that this will change at some point in time, but at the moment that's the case. That's also why module, native federation are not libraries coming from Angular, but from NX or from us or from others. So what's then the main problem, or what is then really the issue where micro frontends can be applied successfully? Whenever you have a big amount of developers who need to work together, and you cannot coordinate, or they cannot coordinate with each other anymore. To put it simply, if you have too many people, that's the point. Then you can use micro frontends, again, with a monorepository. That's the safest approach. They're a little bit of an autonomy. You have a separate deployment process. So this is something which is very beneficial. And you're also getting benefits in the build time. Because if you have separate deployments of parts of your application, that also means that you don't have to build the whole thing all the time, but you build it partially. These are also then advantages you get, but the main use case is really you have too many people. That's the use case. And in the end, or almost at the end, this is the way how I would explain micro frontends if I have to explain to someone who doesn't know what it is all about. It's really mapping or transforming an organizational problem, a people problem, the coordination issue, into a technical one that we can then solve. Because most of us are developers, so we can fix technical issues, not organizational ones. And with micro frontends, we have the option to do it on a technical level. That's the basic idea. Good. Then I have a few minutes left, and maybe I want to say a little bit about the differences between module and native federation. As I said, in the end, it's the same approach. Lazy loaded chunks, you have a remote entry where, again, you have to make sure that the strict versions are kept. It's all the same. The main difference, though, is that module federation is currently based on Webpack, which means we have Webpack also running a little bit in the browser. So there is a certain Webpack format. The import statements, they are understood by Webpack. And this is what module federation is doing. And at the moment, there is not just Webpack, but NX is also working on the RSpec support. But the thing is, during the runtime, you still have this dependency of the bundler. It's still also during the runtime available, not just during the build time, but also during the runtime. What native federation is doing, it's a little bit different. Native federation is using ESBuild during the build time. And it does not require you to run ESBuild or some ESBuild format in the browser. Instead, it says, I'm going to compile to ESM, which is the standardized ECMAScript module system, which means you can use the normal imports that the browser also understands. And the advantage here is that you can also then use other build times for your remotes as long as they can produce ESM. Because during the runtime, it's just a normal ESM import which the browser can manage. That's the idea. But also native federation requires an adapter during the build time. So somebody needs to implement something that says ESBuild, you're producing me my Angular chunks, and you're producing ESM for me. If you want to use Webpack or RSpec to ESM, then this is something where somebody needs to implement an adapter. These are the main differences, I would say, also from a company's perspective. Module federation with RSpec is more, I would say, more related to NX. We also provide a module federation part, But at the moment, we are investing quite a lot into native federation. Yeah. But other than that, I would say I am done, and I would say the thing which I've practiced most, Dhanyavad. I'm not sure if I pronounced it correctly. Yeah. Thank you.